In this video, we will look at two artificial examples to better illustrate the mapper algorithm. To understand software, it often helps to apply it to a variety of examples, especially examples you can visualize to illustrate both the pluses and the minuses of the software. We will start off with the Truffle knot. So imagine we have a data set that basically lives on the Truffle knot. So lots and lots of points covering this knot right here. We will use the filter function projection to the x-axis. This is not a typical filter function that's used, but it is good for illustrating examples. So thus we can take our projection to the x-axis, cover the real line with overlapping intervals, take pre-images of those overlapping intervals to create bins, overlapping bins of our data. So we have this bin right here. We also have the orange bin, etc. All together, we've got 1, 2, 3, 4, 5, 6 bins, all of which overlap. We then want to cluster each bin. So if we take a look at the red bin, we can see we have one connected component, so we have one cluster. For the orange bin, we've got this cluster right here, so this connected component. This connected component, this is a knot in 3D, so this is a separate connected component and thus a separate cluster. And then we have a third connected component for a third cluster. And then remember, we represent each cluster by a vertex. So since we had one connected component, one cluster, we have one vertex here. Since we had three clusters, three connected components, we're going to have three vertices for our orange bin, etc. We also remember that our bins are overlapping. So the points in the red bin, these points right here, they're both in the red bin as well as the orange bin. So these points right here, they're both represented here as well as here. So we've got that these points, they're in both the red bin as well as the orange bin because these bins overlap. And thus we can see that this cluster here overlaps with this cluster right here. So thus we're going to draw an edge. Remember, we draw edges between overlapping clusters. Similarly, this is in both the red cluster, the red bin as well as the orange bin. So we can see we've got over here and over here, these points are the same. And so thus the cluster containing these points and the cluster containing these points, since these are the same, since these points are the same as these points, this cluster here, we're going to get an edge between those two clusters. So we create a graph by clustering each bin. Each cluster is represented by a vertex, and we draw an edge between two vertices if their clusters have points in common. And this gives us a graph. And that graph is, we hope, a good representation of our original data. But there is one thing to warn about in terms of graphs. Graphs are just a collection of vertices and edges indicating, connections between these vertices. How you draw the graph can actually sometimes be misleading. There's lots of different ways of drawing this graph. So, for example, let me label these vertices A, B, C, and D. I can simplify this graph by pulling this edge down. And so all I did is I took the edge that was up here and I pulled it down here. So this graph and this graph, they are exactly the same graph. So Mapper will display a graph, has an algorithm for displaying it, but it's probably not going to be displaying this graph In fact, it probably won't even display this graph. We can simplify it even further. We can get rid of this crossing by taking these edges right here and twisting them. So if I take these edges and twist it, I can undo that crossing. And so this graph here and this graph, where before it was 1, 2, 3, 4, now we twist this vertex over here. So now it's 4, 3, 2, 1 in the opposite order. So these two graphs are the same. Similarly, I can smooth out this thing and draw it in a more circular pattern. So this graph is also the same. So when the graph is displayed, the fact that this edge tilts over this way has no meaning. The fact that this edge is shorter than this, it might have zero meaning. It just might be for better display purposes, for better visualization, to fit in a specific space. Some things might be drawn longer than others, but it might not have any meaning. So all of these, you might want Mapper to display it like this. In fact, you might want the crossings, you might have wanted a different crossing for that. But that's not necessarily what Mapper might display. It might display something more similar to this as well. But in any case, we do have a nice circle representing our Truffle knot. And notice that our Truffle is an embedding of a circle. It is an embedding of a circle. And so it is nice that the Mapper software can pick up the fact that the Truffle knot is the embedding of a circle. And you can see why that is. This component here connects to this. This component here connects over here, connects here, connects here. And you can see that it connects in a nice circular way so that we get this circle here. You can also see that Mapper isn't perfect. We do get an extra flare coming off here, so just an extra flare coming off from here. And that's basically because this is a single connected component. So we have a single connected component right here connecting to this single connected component. And so we did get some flares that really we didn't want them. We really only wanted to see the circular component, but sometimes we get some artificial, some short flares coming off. In other examples, the flares actually will have meaning. So in this particular case, we would like to be able to capture the fact that we've got these flares coming off here. So that would be nice to be able to capture. So we're going to now apply Mapper to this artificial example. And again, we're going to just do projection to the x-axis for a simple illustration. We again will project to their x-axis, take a cover, take the pre-image of those, so the pre-image of each of these intervals, so that we get these overlapping bins. And for each bin, we'll take a look at the clusters. So we've got two connected components here. So for the red bin, we get these two clusters. And for each cluster, we represent each cluster by a vertex. We get two clusters, two vertices. In this case, we have a single connected component, so a single connected component. So we get only one cluster, which we represent by a single vertex. If we take a look at our next bin, so the pre-image of this yellow interval here, we can again see we have a single connected component, so we get a single vertex to represent that component. And if we take the pre-image of this, we again get a single connected component. So again, just one vertex. In our next pre-image, we now see we actually have two connected components. So that means we get two vertices, one for each connected component, one for each cluster. And in our last pre-image, we again get two connected components, and so one vertex for each of the connected components. So that gets us our vertices. we can now get our edges by saying that this connected component intersects with this connected component. They have points in common, so we get an edge here. Similarly, this connected component also intersects with this connected component, so we'll get another edge there, and thus we get a graph by whenever two components intersect, we draw an edge between their corresponding vertices. And that gives us a graph representing this data set. Notice that because we use projection to the x-axis, our graph picks up that we've got these flares coming out. We pick up the fact that we've got these flares coming out. But since we projected to the x-axis, we lost these. Mapper does not pick up these flares that are vertical. They don't pick up the vertical flares. They only picked up the horizontal flares because we projected to the x-axis. So it's not a perfect representation of our data, but it did pick up the circularness of our truffle with a few short flares thrown in, and it did pick up our horizontal flares, though we did miss these flares right here. For more about the importance of flares, see the paper Extracting Insights from the Shape of Complex Data Using Topology, where they apply the Mapper software to analyze basketball players, politics, as well as breast cancer data.